This video is on angles of elevation and depression. We have word problems that will either say angles of elevation or angle of depression. We have to create a right triangle, and then we will solve this using trigonometry, using SOHCAHTOA. So angle of elevation is the angle between the horizontal and line of sight to an object while looking up, since it's elevation. So if we're dealing with a right triangle, I'm just going to draw a basic right triangle. Your angle of elevation is between the horizontal line and your line of sight. So if someone is standing here, they could see something looking up. So our angle of elevation is located here. This is your theta. Now, a way to remember this is that your angle of elevation is always between the horizontal and the hypotenuse. Horizontal and hypotenuse. So between the horizontal, so you would draw an arc from the horizontal to the hypotenuse. It's not going to be located here because this is the vertical. So this is the horizontal. Generally, it's going to be the ground. So what we're going to look at is we need to draw a picture and then determine our trig. Now, you do not have to draw an actual picture of the things that are in here, but we do know that we're going to try and end up with a right triangle. So example 1 says, a person is standing 800 meters away from the base of the Chrysler Building in New York. The angle of elevation to look up to the top of the building is 21 8/10 degrees. How tall is the building? So now we're going to end up having a right triangle in here because we have a Chrysler Building and a ground. So if I just draw the Chrysler Building, if I just draw a little building, basic building, I know it's going to go up. I know it has to be on the ground, so even if I just draw my green line here for the ground, I know and I see that someone is looking up to the top of the building, to that top of that building. So a person is actually standing over here. You can draw a little person, a little stick figure. That person can see the top of the building, and I can create a right triangle. I now have a right triangle. Now all we got to do is just label everything. So to label everything, it says the person is standing 800 meters away from the base of the Chrysler Building. Here's our person, here's the base. So it's 800 meters away from the base. So if you draw a line from the two things it's talking about, the person and the base, that's where you put your number. So 800 meters would go on the base of our right triangle. The angle of elevation, again, always between the horizontal and hypotenuse. Here's our horizontal. Here's our hypotenuse. So draw an arc. To look up to the top of the building is 21 8/10 degrees. So 21 8/10 degrees. Question is, how tall is the building? Tall goes from bottom to top. So this is what we're looking for. We're looking for this x. So now we can go on and actually draw or outline everything. We can figure out our hypotenuse, opposite, adjacent, whichever one we're looking for. So always highlight your hypotenuse. Your hypotenuse is actually this red line, this line of sight. And now we're going to label the triangle like we do with SOHCAHTOA. So our theta is that 21 8/10 degrees. The 800 is attached to that degree but not highlighted, so that's our adjacent. And then our x is located across the triangle, so that's our O. So we have O and A. So we're using SOHCAHTOA again. Still using SOHCAHTOA. O and A is tangent. So we have tangent of theta is equal to opposite over adjacent. We plug in what we have. So we have tangent of our theta is 21 8/10 degrees. Our opposite is our x. Our adjacent is 800. So since we have the denominator, we're going to multiply our denominator to our trig. So we have our 800 times our trig, tangent of 21 8/10, and that'll give us our x. We have to make sure our calculator is in degree mode. So when we turn our calculator on, we go to mode, we check to see if it's in degree. It is, so that means we can go ahead and type this in. So we have 800 times tangent of 21 8/10, close parentheses. We get roughly 319 and 98 hundredths. So roughly 320 meters tall. This is a meter, so I do want to make sure I represent that X is approximately 320 meters. And that is actually true. The Chrysler Building is roughly 320 meters tall. Example 2, it says a ramp is 120 feet long and rises vertically 15 feet. Find the angle of elevation of the ramp. So we know it says it's rising vertically, that's going up, and it's a ramp. So if you're trying to go up a ramp, you know, you're going at a diagonal. So we can draw a picture. So we have a vertical, we have a ramp, and we know it has to be on the ground as well. So now we're going to have a right triangle. So now to label everything. It says a ramp is 120 feet long. So the ramp, it's not going to be the horizontal because that's going to be flat. It won't go any, you won't get up anywhere, and you cannot go up something vertically. So the ramp is that diagonal. This is the 120 feet. Then it says rises vertically. So vertically is up and down. That's the 15. So the 15 goes here. It says find the angle of elevation. Now angle of elevation is between the hypotenuse and the horizontal. So here's our horizontal. And here's our hypotenuse. So we're going to draw an arc here. This is where we put X. Or this is theta. So now to label our triangle with for SOHCAHTOA, I'm going to highlight the hypotenuse, which is opposite the right angle. And now to label. So yes, we do put our theta here. Theta is technically already here. So I'm going to put theta again in orange. Across the triangle is the 15, that's our opposite. On the highlight is our hypotenuse always. We use O and H from SOHCAHTOA, that is sine. So sine of theta is equal to opposite over hypotenuse. So to plug in what we have sine of, we want to find theta, so we're going to put X there because that's what we're looking for. Is equal to our opposite is 15. And our hypotenuse is 120. So if you remember back from SOHCAHTOA, we do, since X is inside the parentheses, we do second sine or sine inverse of the fraction, 15 over 120, and that'll give us our X, that'll give us our degree. So we have second sine of 15 divided by 120. We get roughly 7 2/10 degrees. So X is approximately 7 2/10 degrees. And that should make sense because if you have a steep degree, that makes the hypotenuse go, it's steeper. It's almost like your slope. So you would be going up a very steep ramp and you wouldn't be able to go up that ramp. So you would want it very small so you can actually go up it. Think about a wheelchair ramp. It doesn't want to be too steep, otherwise you can't go up it. Example 3, the length of a wire supporting a radio tower is 175 feet. The angle of elevation to the top of the radio tower from the foot of the wire is 65 degrees. How tall is the radio tower? So we know we're going to have a radio tower. Here's my little tower. We know that the radio tower has to actually be on the ground, so I'm going to have my ground. But it says that there is a wire supporting it. So to keep the tower from falling over, the wire has to support it by holding it up. So I'm going to have my wire going to the ground and supporting it. So, and we know that we're trying to make a right triangle. So now to label everything, it says the length of the wire is 175 feet. So the wire is the red line. So this is 175. It says the angle of elevation. So elevation automatically is between the horizontal and hypotenuse. So horizontal and hypotenuse is your angle of elevation, is 65 degrees. So we put 65 degrees. How tall is radio tower? So from tall is from the bottom to the top. So we're looking for this length right here. So we're going to highlight our hypotenuse now that we have everything labeled. And we're going to label the triangle in orange. So our theta is at 65 degrees. Our X is on the opposite. And the 175 is on the highlight, so that's automatically our hypotenuse. So opposite and hypotenuse is sine. So we're going to have, I'm going to go ahead and write in the purple equation. So we're going to have sine of 65 degrees is equal to its opposite over hypotenuse. So it's x over 175. So we're given the denominator, so we're going to multiply. So it's 175 times sine of 65 is equal to x. So 175 times sine of 65 degrees, close parentheses, is roughly 158 6/10 feet. So x is approximately 158 6/10 feet. That's how tall the radio tower is. Also makes sense because it doesn't want to be too tall, but it also, you can't have it so short to where it won't get anywhere for the radio tower because it is trying to broadcast. Example 4 says a 6-foot tall person standing on the ground can see an airplane at an angle of elevation of 12 degrees. If the plane is 15,876 feet away from the person, what is the approximate altitude of the plane? Okay, so we do have a plane flying in the air, so I am going to draw a plane. My plane looks very sad. Please do not judge my plane. So I have the tail, the wings, the windows. It looks very sad. And I also have a person standing on the ground. So I'm going to draw my little person down here, standing on the ground, little stick figure. Gotta be standing on the ground though. And the person can see the plane. So I can draw from the person. It says a 6-foot tall person can see the plane. So because I know how tall this person is, I should actually put in here that yes, this person is 6 feet tall. Now the person is seeing it, so I actually, from his eyesight to the plane. And then the question is asking what is the altitude, so I need to still draw that vertical in there. So if I draw that vertical in here, I'm going to use brown. Okay, but right here, I didn't go straight to the ground. So actually what we have here, our right triangle comes from here. But the question is asking what is the approximate altitude? So let's go back and put some stuff in here. So we have the 6-foot tall person standing on the ground. The airplane is at an angle of elevation. So elevation is between the horizontal and the hypotenuse. So horizontal and hypotenuse is 12 degrees. The plane is 15,876 feet away from the person. So here's the plane, here's the person. So again, if you draw a line between the two things, that's where you put your number. So from the person to the plane, that's along that red line. This is where we put that 15,876. The question is, what is the approximate altitude of the plane? Altitude is the height, but the altitude is from all the way from the plane to the ground. So we actually want this entire length. However, this part is the only part that's attached to that right triangle. But if you notice this part right here, this is parallel to the ground. And I've actually formed a rectangle down here. If I have this 6-foot tall person, the ground, this length right here is also 6 feet. This length right here is also 6 feet. So I already know part of the altitude has to be obviously more than 6 feet tall. So then what about this part? From the right triangle, this is the part that we're missing. So if I use the letter Y for this instead, because I need to find this part, using the right triangle only right now, if I were to separate this and draw a right triangle, I would have my 12 degrees here, my 15,876 here, and my Y here. My altitude will have to be the entire length, which is x. So x will equal to, I have my 6 feet already, plus whatever I get from this length right here. This is called the segment addition postulate. The two parts of my segment add together to be the whole thing. So I already have my 6, but I have to go up y. I don't know how much y is, but it's going to be 6 plus y. So we have to find out what y is. So now using trig, I want to highlight my hypotenuse, which is still that red line from there. Now I can label things. My theta is my 12 degrees. The y is opposite, and the 15,876 is your hypotenuse because it's on the highlight. So it's sine, it's O and H, sine. So I have sine of 12 degrees is equal to y over 15,876. So yeah, we will multiply because we have the denominator. So this is 15,876 times sine of 12 will equal to y, so that we can find that. So we have 15,876 times sine of 12 degrees is roughly 3,308 tenths feet. So I'm going to put that y is approximately 3,306 tenths feet, 8 tenths feet. So now I can say it's really, so it's x equals 6 plus 3,308 tenths feet. Then just add them together. X is approximately 3,306 and 8 tenths feet above the ground. This is the harder type problem. If you notice on these, all the other problems that we've done on here, there's only two numbers. You have your 800 meters and 21 8/10 degrees. 120 feet, 15 feet. 175 feet, 65 degrees. But here we have three numbers. We have 6 feet, 12 degrees, and 15,876. When you have three numbers, you're going to have to do something extra with that. You're either going to add something or subtract something before you begin or after you end. So you might have to add the number before you do your trig. You might have to subtract your number before you do your trig. You might have to add your number after you do your trig, or you might have to subtract your number after you do your trig. It all depends.